and welcome to this online College of Coding video tutorial series. This is video 4 in the series of intermediate breaky blocks in Unity. In this video, we'll be creating bricks that we can break with our game's ball. Before watching this video, it's recommended you've seen the previous videos in the series, as well as the introduction to Unity videos and the intermediate programming concept videos. Let's get started. Now that our ball can bounce against the walls and the paddle, we need to add some interactive objects for it to bounce into, some bricks. To have bricks in our game, we first need to import the brick asset package. The brick asset package contains 5 different textures we can use for our brick objects. If you click through them, you can have a look. Click the import button, and in the hierarchy, now we click the create menu, and you guessed it, we need to create a 3D quad. Use the inspector to change the name of the quad to brick, and in the transform component, set the position to 0, 0 if it isn't already, and then set the scale to 1 on the x-axis, 0.5 on the y-axis, and 1 on the z. This makes the brick brick-shaped. In the inspector, find and remove the mesh collider component, just like we've been doing for all the rest of our objects, and click the add component button, and just like we did for our paddle, we're going to add a box collider 2D. For the moment, this is our brick sort of done. We just have to apply a texture and add a script. Now let's create the brick manager that's going to control the spawning of our bricks into formations. So in the hierarchy, we're creating an empty game object and renaming it to brick manager. Leave its position at 0, 0, 0 and use the add component button to scroll all the way down and add a new script, also called brick manager. Make sure the language is C# and press create and add. Now go to the assets folder and drag our script into the scripts folder as usual. Then open it up and add the following code in MonoDevelop. To create a row of bricks, we need to think of what variables and resources we need in our script. Because we're going to be creating things, the script will need to know about a prefab. This will need to be a prefab of the brick. We also need to assign a material to the prefab to give the actual brick appearance. For this, we need our script to know about all the different brick materials. The script will also need to know how much room it has to create bricks between the 2 walls. That's what our level width and bricks in row variables are for. We've created our script and worked out what resources we need. Now we should go back to Unity and create them. We eventually want to delete the brick from the hierarchy so it isn't there at the start of the game. So we need to create a prefab of it. But before we do that, we're going to use it to create materials out of our textures, just as a shortcut. One by one, drag each of the different brick images onto the brick game object in the hierarchy. By dragging each of our textures onto the brick, it automatically, in our materials folder, creates a material for them. This could have been a bit tricky otherwise. Now let's just quickly create the brick prefab. Click on the prefabs folder in the project browser, and click on the brick in the hierarchy. Quickly change its mesh renderer material to be default material, and then drag it down into the project browser to create the brick prefab. Then we can delete it from the scene. Select the brick manager, and into the brick materials list, we can go to our materials folder and drag each of the brick materials. We also have to drag our brick prefab into this brick prefab slot. So if you go to the prefabs folder, you can do that now as well. Now we can go back into our brick manager script and organize for it to pick a random texture to apply to our brick prefab every time it creates a brick. And while we're at it, we're going to get it to create a row of bricks for us. Let's go. The variables we added to the script in the first pass now have all been linked up and are ready to be used. Because we're going in steps, we start by creating just a single row of bricks in the middle of the scene. We use the start function to calculate the number of bricks that will fit in a row. This information is needed later on in the script. Next, we simply call the spawn brick row function. The first line of that function starts a for loop that uses the freshly calculated bricks in row variable to run once for each brick. We start the loop's iterator I at 1 instead of traditionally at 0. To leave a gap between the bricks and the wall. Then we create and use the current brick variable to hold the value of the brick so we can access it for the rest of the loop. Next we create a random number and store it in the rand variable. This random number corresponds to one of the different brick material items. On the next line, we use the getComponent function to access the brick's renderer and assign it the material from the list that corresponds to the random variable's value. The last line of the for loop calculates the position of the brick within the row. Let's just quickly jump back into Unity and double check our code works. Now that we have one row of bricks spawning in our scene, we need to expand the script so that it spawns more rows. Let's begin by working out what variables we'll need to add for that. For starters, we need to know how many rows we want to spawn, and we'll also need to know the position of the last row we spawned so that we can stack the next one on top. With those two variables, it should just be a matter of repeating the spawning over and over. In the start function, we set the next brick spawn height to be the current Y position of the brick manager. This will spawn the first row at the exact same height as before. To begin and repeat the spawning process, we have a for loop around the spawn brick row function that will repeat it once for each row that must be spawned. Once we've spawned an entire row within the spawn brick row function, we need to increment the brick spawn height variable to set it up for the next row to be spawned on top of the previous one. We're also using the next brick spawn height variable to calculate the height for each brick row. We increase its value by the brick's scale, which is exactly the height of one brick, and multiply that by 1.1. So therefore we're allowing for a gap of 0.1 or a tenth of a brick in between each row. Save your script and return to Unity, and select the brick manager in the hierarchy and set the row count variable in the inspector to be 8. 1, 2, 3, 4, 5, 6, 7, 8. Awesome, 8 rows. Works pretty good. The next feature our bricks need is the ability to be destroyed by the ball. For this, we need to add a script to the brick that catches the event of a collision with the ball and then tells the brick to destroy itself. Select the brick prefab in the prefabs folder, and then in the inspector, click Add Component and scroll down to New Script. Name the script Brick. Make sure the language is set to C#, then press Create and Add. As usual, we've got to move the brick from the Assets folder into the Scripts folder, and then open it up in MonoDevelop. Each time the brick is involved in a collision, we're using the getComponent function to grab the attached ball script from the other game object involved in the collision. Conceptually, this is a weird little piece of code that takes advantage of how the getComponent function works, by assuming that the other game object will have a ball script attached. In almost any other area of programming, you can't just assume because you would cause errors when the script can't be found. But Unity's getComponent function assigns a null value to the variable if no script is found. So by checking the value of our variable after we attempt to grab the script, we can determine if the game object has an attached ball script or not, and therefore whether it's a ball and how we should respond. Basically, if we work out that we're colliding with the ball, then the brick is destroyed. Save your code and return to Unity. Now test the game, and every time the ball bounces off a brick, it destroys it. If, when you start your game, a couple of bricks go missing, you might want to try just moving the paddle down in the scene. If you zoom out a bit and select the paddle in the hierarchy, you can just drag the Y value all the way down, or even just set it to -4. Problem solved. So in the very, very, very beginning of the game, for a brief moment, the ball, when perched on top of the paddle, was actually touching a couple of bricks. Well done, you've reached the end of the 4th video in the series. Tune in the 5th video where we're going to finish off the bricks and add some power-ups. See you then.